Hello student, good morning. I am Dr. Kumar Sinha, Professor of Chemistry. Today I am going to discuss half-life of a reaction. Half-life of a reaction. Last class I have discussed rate constant, expression of rate constant for gaseous reaction, and also I discussed numericals. Now I am going to discuss half-life of a reaction. Here just a meaning of half-life of a reaction you should understand. Actually any reaction it takes a infinite time to react completely, means 100%, infinite time. Because in the beginning reaction will be fast. After that it becomes slow, and it takes infinite time to finish it completely in a normal way. Okay. Then if you want to know that half of the reaction time taken for half reaction, means to complete half reaction, that time is called half-life of a reaction. Why? What is the need for this half-life? Then now you understood, because for the complete reaction it takes infinite time. Then it is better to understand half-life. How much time? Means time taken to react 50% of the reaction. 50% of the reaction. Then that time actually is called half-life of a reaction. Then here again very simple way I want to tell you derivation. There is expression for half-life for both, for zero order, for first order, for second order, for third order, for all. But at your level, means for medical and engineering, up to first order, zero order and first order is important. Okay. When I will start for specialized for UPSC, then I will go for second and third order also. Sometimes that also is required for you people who is preparing for engineering advanced IIT, sometimes, not always. Okay. Then now how will you derive the expression? Then it is very easy. You will ask how I am telling easy. Then here you should remember expression for first order or second, this zero order or first order. Okay, zero order or first order, what is the expression? Expression of rate constant K. That is must. Always you keep in your mind. That expression always you keep in mind, because if any question is asked from this chapter, then without that expression you will be not able to solve, particularly numericals. Okay. And so always you keep in mind zero order and first order reaction, means expression for these things K, reaction constant or rate constant. Then there, if you are remembering the formula or expression, then very easy you can derive the T half. How? Then see, in expression for K, as for example, for zero order, first I will discuss. For zero order, that K is equal to R0 minus R divided by T. This is the expression for K, means rate constant. K is equal to R0, means initial concentration, minus R, means concentration at any time, divided by T. Then here, by concept of half-life of a reaction, means half-life of a reaction is the time in which the concentration of a reactant is reduced to 1/2 of its initial concentration. It will reduce to, means it will decrease to 1/2 of the initial concentration. Suppose it was 50 m, you have taken 10 mole per liter, then if time taken to convert it into 5 mole per liter, because with the time concentration decreases. Then suppose 10 mole per liter was there, now if it becomes 5 mole per liter, means 50%, then at what time it will happen? That period is called T half. Then calculation I am talking you for T half. How will you calculate? Then K is equal to R0 minus R divided by T. Then here R0 you require, but here R means concentration at any time. Concentration at any time. That means what? This value will be equal to, means R value will be equal to half of initial concentration, means R0 divided by 2. This is the only important thing. Concentration at any time, that R for the half-life period, that R will be half of initial concentration, means R is equal to R0 divided by 2. That's enough. Just in formula, in expression, you put this value and just you will get the time you will get, T expression you will get. But here T you should write T half. T and half 1/2 you have to write. Below the time T 1/2 you write, 1 divided by 2. Then easily you will get nothing. This is the only thing. After that simplification is there. That's enough. Then here in the place of R, now you will write R0 by 2. R0 by 2. And down in the place of T you should write T half. T and 1/2. Down T 1 divided by 2, a small t, a small t 1/2. In the place of T, you will write T half. T and down half you should write, 1/2. Then that's enough. After that you simplify it. Then you will get, you just do cross multiplication. In the place of K you bring the T half. Or in the place of T half you bring K. Then after the solution, after the simplification, the very simple way, just it become R minus R by 2. Then what will remain? R0 minus R0 by 2, just like 1 minus half, that is equal to half. 1 minus half, that is equal to half. It means R0 minus R0 by 2. Then what will remain? R0 by 2 will remain. Then now you got the formula. T half is equal to R0 divided by 2 and down will be K. Means numerator R0 and denominator you will get 2K. That's enough. This is the expression for T half. And here you have to see in this expression, that is this R, K and T half. It is related with these three only. That for a zero order reaction, that T half for a zero order reaction is directly proportional to initial concentration. R0 is there. Then you got expression T half is equal to R0 divided by 2K. Then T half is directly proportional to initial concentration for zero order. Remember, because this question is asked every time. It is fixed. You can tell this question is fixed for almost all examination, all competitive examination. Then that it is a zero order reaction is directly proportional to the initial concentration of the reactant and inversely proportional to the rate constant, because K is down. Then inversely proportional to K means rate constant, or directly proportional to initial concentration of the reactant. That's enough. Now first order, come to the first order. How will calculate T half? Then here again nothing you have to do, same things. You first write the expression of first order, means K is equal to 2.303 divided by time, means T, log R0 upon R. This is the expression for first order. Always remember this expression only. After this only, by arranging you can get other form, 2 more form you can get. But only this formula I keep in mind always. K is equal to 2.303 divided by T log R0 divided by R. Then again same technique here you have to apply. What you have done for the zero order, half-life for zero order, same thing here. R0 divided by R. Then again here R is equal to R0 divided by 2. R is equal to R0 divided by 2. Same things. Then now you put the value there. Then what you will get? Now again you can say in the place of T you write a T half. Correct? And in the place of R you write R0 divided by 2. Then you will get K is equal to 2.303 divided by T half log R0 divided by R0 divided by 2. Then after simplification what will happen? R0 will be cancelled out. 2 will go up. 2 will go R0 divided by R0 by 2. Correct? Then 2 will go up, and then what will remain? R0 will be cancelled out. Then with the log only 2 will remain, a log 2. Correct? R0 divided by 2. Correct? Then only 2 will remain. R0 will be cancelled. Then now you got the value T half is equal to, now you do cross multiplication. In the place of K you write T half, and in the place of T half you write K. Then T half is equal to 2.303 divided by K. Now it became log 2 because R0 cancelled. Okay. Then now here log 2 value, you know, value of log 2, that is equal to 0.301. Always remember. See, log 10 is equal to 1, you know. Log 2, log 3, log 4, you have not remember, because log 4 means 2 power 2, 2 log 2, just to multiply it by value of log 2. Okay. And for 4 you need not require. 5 you have to remember. 5, 6 also. If you want you can calculate also, because 6 you can write 3 into 2, that is 6. Then log 3 plus log 2. Then log 3 value you are knowing, log 2 is well, you will calculate, you are also knowing log 3, log 2. Then now 6 is also not required to remember. If you are knowing the log 3, log 2, easily you can calculate, because log 6, that you can write log in bracket 3 into 2. then log x into log y is equal to what? Log x plus log y. Then 5 also you can, 6 also you can quickly you can write. 7 you have to remember. 7 you have to remember. 5 and 7. And 8 also need not required. Because 8, 2 into 2 into 2 into 2, 4 and 4 into 2, 8, 2 to the power 3, 2 into 2 into 2, 2 into 2, 4, 4 into 2, 8, and 2 power 3, and 3 log 2, 3 log 2. This also you have to not remember for 8. For 8 also not required to remember. Simply by, if you are knowing the log 2, you can know the log 8. Log 9 is also not required. Log 9 is also not required to remember. Because 3 power 3, 3 power 3, 3 into, not only 2, 3 into 3, 9. 3 into 3, 9. And 3 power 2, 2 log 3, log 3 you are knowing. Then like that way only 5 and 7 you should remember. Then in examination it will be very, very useful for you. Directly you can put the value and get the result, because in examination time is very, very important. Correct? And if you will solve some numericals, then directly log 6, log 7, log 8, log 9 will be automatically, it will be in your mind, because you will use several times same value. But I told the one way how to calculate. If you are not remembering, then you can do like this also. It will not take too much time. Correct? Then log 1, for first order also you can calculate very easily. Now T half is equal to 2.303 divided by K log 2. Then now log 2 value you put, then you will get T half is equal to 2.303 into 3 into 0.301 divided by K. You multiply both. 2.303 into 0.301, it is upside. That is the numerator, it is there. Down means in denominator K is there. Then 2.303 into 0.301, you will get 0.693 divided by K. T half is equal to, for first order, T half is equal to 0.693 divided by K. And then now you can say that now T half for first order reaction is independent of initial concentration. It is not depending upon initial concentration, because term is not there. Only K is there down. In denominator, it means T half of first order reaction is inversely proportional to K, means rate constant or rate of reaction. This also you remember question is asked for this also. For zero order, it is depending on both initial concentration and K, that is inversely proportional. Here also depending only on K, that is also inversely proportional. In both cases inversely proportional. Okay, but in zero order this directly proportional to initial, but here independent of initial concentration, does not depend upon the value of initial concentration. Okay, no use, no need here. Then this I have discussed you that expression for zero order and first order. Okay, then now one numericals I will solve it. Two numericals I will solve it, then it will be clear. Okay, and same type of value may be different, data will be different, but process will be the same. Okay, then I am reading the question, then I will explain it. Okay, A first order reaction is found to have a rate constant K is equal to 5.5 into 10 to the power minus 14 per second. Okay, this is the K, expression of K for first order. Unit also remember per second only, per second. Okay, and mole per liter is for zero order, mole per liter per second. Per second is common in for zero also, first also. Correct? Then here now I told you per second. Half life for a first order reaction, now you are knowing T half is equal to 0.693 divided by K, and K value is given. K is equal to 5.5 into 10 to the power minus 14 per second. Okay. Then now actually half life we wanted to calculate, then T half is equal to 0.693 divided by K. You put the value, you will get the result. Very easy. Then now after putting the value and solving, you will get 1.26 into 10 to the power minus 14 second. That is the T half value. Now next question I am reading and then I will explain. Okay. Question is, so that a first order reaction time required for completion of 99.9% is 10 times of half life of the reaction. This question is very, very important. This type of question will be asked. Okay. Then here again just a question, try to understand. Again I am reading. So that in a first order reaction, time required for completion of 99.9%, not half, time required for completion of 99.9% is 10 times of half life of the reaction. Means here you have to prove, that means you have to calculate T half, and T half value into 10 that will be the, you can say, time required for 99.9% completion. Means with the use of T half of this reaction, value of time required for completion of 99.9%, roughly 100%, that you have to show that for 99.9% value is time, its time is equal to 10 times of T half, 10 times of T half of this reaction. This you have to prove it. Then now here first order reaction is there. This is for first order reaction. Then here first you have to find out K value. Find out the these things what they have given. So that first order reaction, for a first order reaction, time required for completion of 99.9% is 10 times that of half life of the reaction. Then here you know the K is equal to 2.303 divided by T log R0 upon R. R0 means initial concentration is above. Okay. In the numerator, always keep in mind this formula Already told you, remember always. Then now here this formula only you have to use to calculate the time. T value you have to calculate. Okay. Then here what value will put for the R? R0, okay, you will keep for the R0 you can keep. For R, what you will keep? Concentration at any time. Concentration at any time means 99.9% of R0. Correct? That is the R value. Only these things you have to understand in this question. Question is very important. I am telling you. Very less number of students will solve it. If you will solve it, then you will be in the race. I am telling you. 90% students will get confused. Then here I am telling you R value, from where you will bring R value. Then R value, that is the, suppose total initial concentration was R0, initial concentration. Then now this 99.9% finished of R0, 99.9% of R0, it is finished. Then what is remaining? That is the concentration. That is the remaining concentration. Then from the R0, this value decrease 99.9% of R0. R0 minus 99% of R0. That difference of reactant is remaining. Okay, is remaining. That is the R value here. R value. Then in the place of R value, you will write R0 minus 0.999 R0, because percentage there 99.9% means down you write 100 into R0. Then it will become 0.999 R0. Then R0 minus 0.999 R0. Then what is the difference of these two? Then its difference will become minus actually 0.001. Okay, that is a 10 to the power minus 3. You can write 10 to the power minus 3.001. That you can write 10 to the power minus 3. Then now this equation means K is equal to, now it became 2.303 divided by T log R0 divided by R0 minus 0.999 R0. And after this down means denominator, if you solve, then it will come, that is the 0.001. Okay, then now you got the value of K is equal to 2.303 divided by T, 2.303 divided by T log 10 to the power minus 3. 0.001 means what? 1 upon 10 to the power 3. It will go up. Okay. Then now you got the value 10 to the power minus 3, log 10 to the power minus 3. Then this is the value of K. Then what is the T value? Then just now do cross multiplication. In the place of K you write T. In the place of T you write K. Then T is equal to, now you got 6.909 divided by K. Correct? Now you got the value T is equal to 0.6909 divided by K. Okay, because log 10 power 3 is there. then 3 log 10, then you have to multiply log 10 power 3, then 3 log 10 value is 1, then 3, just simply 2.303 into 3, you will get 6.909 divided by k. This is the value of t. Then now this t value you are knowing in terms of k. In terms of k, you are knowing t value. Time required to complete 99%, 99.9%. Okay, reaction completed. Then now you have to compare it with t half value. This t value, and you have to compare this t value to the t half value. Then obviously you will get 10. Value will come 10. T divided by t half value. Obviously, if you write the expression for both, for this value, what you calculated now, t is equal to 0.909 divided by k divided by t half value. If you write, then all term will cancel, only 10 will remain. 10 will remain, means t is equal to 10 into t half. This is the proved. Now here just to compare t divided by t half, then t is equal to 6.909 divided by k, and t half value for first order, you know. T half value for first order reaction, you know that 0.693 divided by k. 0.693 divided by k, that is the half-life period for first order. Then if you will put the value of t half means you are comparing t divided by t half, then now you will get 6.909 divided by k, and down is t half, then you will write k divided by 0.693, reverse it, then both k will be cancelled, then upside 6.909 is there, and down 0.693 is there. Then you will get approximately, I will get 10 times only, because upside is 6.909, down is 0.693. Okay, 2 digit you compare 2 digit, 6.9 and divided by 0.69. 6.9 divided by 0.69, only 2 digit to compare, then only 10 will remain. Then now it is proved, t upon t half, that is equal to 10. Correct? Then this I have discussed these things, numericals. I think now it is clear. Okay. Then many actually this question is asked. Many question is asked on this concept. Okay. Then formula, what I told you, t half formula for both you remember, and just expression for zero order and first order you always remember. Okay. Then now I have discussed numericals. Now I am going to discuss pseudo first order reaction. Pseudo, PSEUDO. P is silent here. PSEUDO, pseudo. PSEUDO, pseudo first order reaction. What is this? Then here I am telling you very simple way that what is a pseudo first order reaction. Then also it is called pseudo unimolecular reaction. Pseudo unimolecular reaction or pseudo first order reaction. What does it means here? If molecularity is 2 in any reaction, if molecularity is 2 and order of reaction is 1, then that type of reaction is called pseudo first order reaction or pseudo unimolecular reaction. If a molecularity is 2 and order of reaction is 1. Then example I am telling you, you always, this also reaction also you always remember, that is the ethyl acetate, hydrolysis of ethyl acetate, okay, means CH3 COO C2H5 plus H2O. It gives, actually in acidic medium H plus, in the presence of H plus means acidic medium, it gives acetic acid plus ethyl alcohol means C2H5OH. Then actually this is ester, ethyl ester, okay, CH3 COO C2H5, it is ester, ethyl acetate. Then this ethyl acetate plus H2O in presence of H plus means hydrogen ion in acidic medium. Actually H plus here function as a catalyst, acid catalyzed. This reaction is also called acid catalyzed. Then it gives acetic acid plus ethanol C2H5OH. Acetic acid is CH3COOH and ethanol is C2H5OH. Then this reaction is the example of pseudo unimolecular reaction or first order reaction. Here water is in large excess. Water is in large excess. Remember it. Okay. The order of a reaction is sometimes altered by conditions. Consider a chemical reaction between two substances when one reactant is present in large excess, as for example H2O. During the hydrolysis of, I am giving a specific example, during the hydrolysis of 0.01 mole of ethyl acetate means 1 upon 100 mole, 0.01 mole of ethyl acetate with 10 mole of water. See, 100 times water molecule is more, correct? 0.01 mole means 1 upon 100, and water is, you can say 10 mole of water, 1 upon 100 and 10 mole water. See difference? Then water is in large excess. Then this, what happened, 10 mole of water, suppose this reaction is going on. Then here you can say reaction will take place. This during the hydrolysis of 0.01 mole of ethyl acetate with 10 mole of water, amounts of the various constituents at the beginning, that is that T is equal to 0, and completion that is the, you can say time of the reaction, Suppose this data is given that at 0 time what is the reaction, at 5 minutes what is the reaction, means what concentration is remaining, after 10 minutes what concentration is remaining, and after 15 minutes, 20 minutes, 30 minutes what concentration is remaining of ethyl ester, that then you know that with the time this concentration will decrease, and in the end, that is called time required at infinity, T infinity, that is called T infinity, okay, at infinite concentration, at infinite time, means when reaction is going to be completed, what is that time? That time is called T infinity, okay, time required to finish a complete reaction, that is called T half. Then now here, suppose data is given, it is experimental data, that in the beginning means when time is 0, that time concentration is 0.01 mole, and this when time is equal to 0, then no reaction, means concentration, there is no reaction. Okay, but at different time, now concentration will be different. Then now suppose at 0 degree, means the beginning, can say in the beginning concentration was 0.01 mole, and at the end when reaction is completed, then now it became 0. All ethyl state converted into the acetic acid and ethanol. Okay, then in the beginning when T was 0, concentration of ethyl state was 0.01 and water was 10 mole, and that time when T was 0, acetic acid was 0, no acetic acid was formed, no ethanol was formed. But at the end, when reaction completed, it became 0. Then here water actually will be almost constant, 10 mole water was there. Then after the reaction, full reaction, it will be almost constant, means 9.9 mole is remaining. 9.9 mole is remaining because water was in large excess. Okay, then almost constant, and it has given acetic acid and ethanol. How much? Then it has given 0.01 mole. 0.01 mole it has given acetic acid, and again same quantity 0.01 mole ethanol they have given. Correct? Then here rate is equal to what? For this reaction, what will be the rate? Then rate is equal to K dash, you can write K dash, molar concentration of ethyl acetate into molar concentration of H2O. Okay, this rate will be equal to K dash into molar concentration of ethyl acetate into molar concentration of H2O. But here you can see very important things. The term H2O can be taken as constant. H2O can be taken, concentration of H2O can be taken as constant because very little change is there. Very little change. Just like from the ocean you have taken 1 bucket water. Then what will be the effect on ocean? Correct? At same way, here out of 10 mole, 9.9 mole is remaining. Very less used up. Then that's why you can tell that concentration of water is constant. Then now what you will write here? Rate is equal to now you can write K into ethyl, molar concentration of ethyl acetate. Only rate is depending upon concentration of ethyl acetate because H2O became 0, power is 0. That means 1. Then only what you have written that time K dash, now you can write only K. Then rate is equal to K into molar concentration of ethyl acetate into 1 because H2O, this H2O power 0, that become 1, means only ethyl acetate. Rate depends only on the ethyl acetate. Okay. Then now you can write here K you have written, means K is equal to what? K dash into H2O. Okay. In the beginning you have written K dash when both terms were present, but now you are writing only K. Then here K means what? K means is equal to KH2O, K into H2O. Okay, new constant you have written K is the new constant, that is equal to K dash H2O. Here H2O is constant. Hence main reaction rate of the reaction depends only upon ethyl state. Negligibly you can say on H2O. Then rate is equal to K into molar concentration of ethyl state simply. Then here you can define this pseudo unimolecular reaction. That reaction actually here reaction behaves as a first order reaction. First order with respect to ethyl state and zero order with respect to H2O. Then such reactions are called pseudo first order reaction. Pseudo first order reaction when this molecularity is 2. Here molecularity is 2. Balance equation is this is the balance equation. Then 1 mole ethyl state, 1 mole is 2O. Then molecularity is 2 and this order of reaction is 1. Okay. Then this I have told you about the pseudo unimolecular reaction. Now second example I am telling you, that is this inversion of cane sugar. Inversion of cane sugar. Cane sugar means what? Sucrose, C12H22O11. That is the cane sugar. Then this cane sugar plus H2O, again same way, in presence of H plus. H plus means in presence of acid. This is also acid hydrolyzed reaction. Then this reaction gives two products, glucose and fructose. Glucose is C6H12O6. Fructose is also same formula. Both are isomer, same formula. Okay. C6H12O6. This is also C6H12O6. Then now you are getting cane sugar is producing glucose and fructose. Then here again reaction rate you write, then rate will be K into molar concentration of cane sugar, means sucrose, K into C12H22O11. This is also the example of pseudo unimolecular reaction or pseudo first order reaction. Here also molecularity is 2. 1 mole of cane sugar plus 1 mole of H2O. Then I think now you have understood what is pseudo unimolecular reaction. Okay. One numericals is there. I am telling you, already you have understood, but question is asked. Okay. Then I am telling you that numericals. I will explain you. First question I will read, then I will give explanation. Hydrolysis of methyl state in aqueous solution has been studied by titrating the liberated acetic acid against sodium hydroxide. The concentration of the ester at different times is given below. Now data is given. Time is in minute, means at 0 time, and concentration is mole per liter. Concentration is mole per liter. Then when time was 0, concentration was 0.8500. And at 30 minute, concentration became 0.8004, means it is decreasing. At 60 minute, concentration decreased to 0.7538, again decreased. And 90 minute, again further decreased, 0.7096. Okay, means at a different time concentration of methyl state is given. Okay, at a different time different concentration is given. Now what you have to do according to the question, so that it follows a pseudo first order reaction as the concentration of water remains nearly constant, means 55 mole per liter. Water concentration is 55 mole per liter. During the course of the reaction, water concentration was almost constant, 55 mole per liter. What is the value of K dash in this equation? K dash value you have to calculate. Then K is equal to K dash into H2O. That relation don't forget. K is equal to, K is a new constant, then K is equal to K dash into molar concentration of H2O. It means you want to know the value of, I can say K dash, then you should know the value of K, and you should also know the value of H2O. H2O concentration, that value is given. H2O concentration is given 55 mole per liter. Then K value you have to find out, K value. Then you are going to find out the K value. Then here pseudo first order reaction, the reaction should be first order with respect to ester when H2O is constant. Okay, the rate constant K for pseudo unimolecular reaction. Now you are knowing, you know the same expression for first order you are using here. K is equal to 2.303 divided by T log C0 upon C. C0 upon C, C is the concentration at any time. Then here already you know that K is equal to K dash H2O, that you remember. Then now you have to calculate the K value. Then here at a different time, different concentration is given. Okay, actually this type of question is asked in all examination, even the competitive examination also, in board examination also, university examination also. Okay, then you have to just to make one these things column, you have to make 3 column, you have to make that at 0 time what is actually concentration given, that you know at 0 time. As first column you for the time you make one column for time, other column you make for the concentration, and third column you make for the what you have calculated, what value, K value per minute you can calculate. 3 column, first column for time, second column for concentration, third column for K value. Then after that, because you have to compare, okay, you have to see all the result. Then now at different value, K value you have to calculate. Means when time was 30 minutes, 0 time you will not calculate. 30 minutes, we start with 30 minutes. Then when time was 30 minutes, what was the, you can say, concentration? Then C0 concentration, you know, C0 concentration was 0.88500. Then C0 value is common in all calculation. This value will be common. Only at 30 minutes, 60 minutes, 90 minutes, that value will change. Then K value at 30 minutes, means K30 you can tell. You can write 0.8500 divided by at 30 minutes what was the concentration, that you have to write, means 0.8004. Then after that if you will solve it, then you will get the value 2.004 into 10 to the power minus 3. This value will get at 30 minutes. Same way at 60 minutes, again this C alpha, C0 value will be same. 0 concentration value will be the same, means 0.8500 divided by now at 60 minutes concentration is given 0.7538. That value write and solve it. You will get the result. K value will get 2.002 into 10 to the power minus 3. And third at 90 minutes, then at 90 minutes, that is K90, K30, K60, K90 you are going to calculate K value. Then again C0 value will be same, 0.8500, and concentration at 90 minutes, that is 0.7096. After putting this time value you are writing the first case t is equal to 30, in second case 60, t is equal to 60, in third case t is equal to 90. Then after putting this value you have solved. Then now in the third case you will get 2.005 into 10 to the power minus 3. Then now see the result. 10 to the minus 3 is the common in all, and K value is in first case 2.004, in second case 2.002, in third case 2.005, almost constant because 10 to the power minus 3 in all three cases. Then it can be seen that K dash H2O is a constant, correct? This is the K value. K value you can take the average of all these three. Then almost same real value will come because difference is very less, 2.004, 2.002, 2.005. Then you can take the average of these three. It will come almost same. 10 to the power minus 3 is the common. Then this is the K value. Then K is equal to K dash into molar concentration of H2O. Then H2O concentration is 55 mole. And K value, average value you can take of these three. And any value you can write, that will also work because all values are almost same. Then K value are knowing, H2O value are knowing, hence K dash value you can know very easily, correct? Then this K dash H2O is constant and is equal to 2.004 into 10 to the power minus 3 per minute. That you can take, that is the first 30 minutes you have taken. 30 minutes, that value only you can take, no problem. Then K H2O, that is equal to 2.004 into 10 to the power minus 3 per minute. Then K dash into 55 mole per liter, you know, that is equal to 2.004 into 10 to the power minus 3. Then K dash is equal to what? Just 2.004 divided by 55, upside 10 to the power minus 3. Hence you will get the result. 3.64 into 10 to the power minus 5. K dash value after solving 2.004 into 10 to the minus 3. It is upside, down is 55. Then you will get 3.64 into 10 to the power minus 5 mole per liter per minute, correct? Then this type of question is asked, okay? Then now data may be different, many questions will be there, and only data will be different, but method of solving is the same. Never you just fear from the numericals, okay? Because now all things you are knowing, each and everything I am discussing, and there is no question of not solving the question, numericals. Only you should not be nervous. Try to understand the question, try to remember the formula, and any, you can say, minor change if you have to do, suppose time you have to convert into second, or second you have to convert in minute, hour, like that way, that gram, sometimes kg, all the things in general I'm talking about, that should be careful, correct? Then easily you can solve any numericals of any chapter. Okay, but you should not nervous. That is the first thing. Okay, then you should not be nervous. Keep your mind cool. Remember this formula, and try to start from the what you want. Only from that back calculation you go. What you require, then what is the things which you required. How will you get that things? In a question what they have given. Sometimes in question unnecessarily things they will give for temperature and pressure. You will not require. Sometimes require, sometimes you don't require. Simply they will make a long question. They will give the name of instrument. They will give the name of process to make the question big. They will try to confuse the student because their intention is to reject the student. But you should think that you should not be rejected. Okay, you should try like that. You apply your mind. Then this I have discussed these things, numericals also, and pseudo unimolecular reaction, half-life period also. Now I want to discuss temperature dependence of the rate of a reaction, means how temperature affect the rate of reaction. That is called actually temperature dependence of rate of reaction. But it will take time, more explanation is there, and it is very, very conceptual and not tough. After understanding, you will not feel tough. Now today I am stopping only here. Next class I will start effect of temperature on rate of reaction. Thank you.